Hi students, welcome back to computer class. So we have completed our first chapter and now we are moving on to the second chapter, that is number system. What do you mean by a number system? See, in our earlier days, the ancient people for counting objects, they started using numbers like 1, 2, 3, 4, and later on a larger system came, and that system is known as number system. A number system is a notation for representing the numbers of a given set by using various digits or other symbols. Okay, number system, it is a system that has been used for representing numbers by using digits, symbols, etc. Okay, and there are four types of number system. First one is decimal number system, second one is binary number system, and third one is octal number system, and fourth one is hexadecimal number system. Okay, the four types of number systems are: first one is decimal number system, binary number system, octal number system, and hexadecimal number system. Okay, so a number system means it is a system in which the numbers, they are represented by using the various digits. For example, 1, 2, 3, 4. Okay, and they can also be represented by using other symbols. This is about number system. So in this chapter we'll be studying in detail about these four types of number system. Okay, so first let us study about decimal number system. Okay, in decimal number system there are totally 10 digits. They are from 0 to 9. Okay, in decimal number system there are 10 digits and they are from 0 to 9. And the base of a decimal number system is 10. What do you mean by the word base? Base, they tell us the total number of digits that are present inside a number system. We know that in decimal number system there are 10 digits. Okay, so the base for decimal number system will be 10. Base means they tell us the total number of digits that are present in a number system. In decimal number system there are 10 digits. Okay, so the base for a decimal number system will be 10. And this base, they can be placed as a subscript of a number. See, for example, 547 subscript 10. Okay, denotes the decimal number 547 with the base 10. We know that a decimal number system, they have got a base 10 and 547 is a decimal number. Okay, so the base for that number will be 10. Okay, so 500, we can write this as 547 subscript 10. That is a base, they can be written as a subscript of a number. Okay, once again, 547. 547, it is a decimal number and we know that the base of a decimal number is 10. And this base, they can be written as a subscript of a number. Okay, so we can write 547 subscript 10. Okay, so once again, decimal number system, they have got 10 digits ranging from 0 to 9. And the base of a decimal number system is 10. Okay, and we can write this base as a subscript of a number. For example, 547 is a decimal number and its base is 10. Okay, so we can write this as 547 subscript 10. That is, we can write a base as a subscript of a number. In a number system, the value of a number depends upon their position. Okay, and this is known as positional value system or positional value notation. In a number system, the value of a number depends upon the position. Not only on a digit, but a value of a number depends also on position. And that is known as positional value system or positional value notation. And the definition for this positional value system is, it is a system where a number is defined not only by their digit but also by their position. Okay, a number is defined not only by the digits but also by their position. For example, let us look how we can represent a decimal number 1234 with their positions. Okay. Let us see how we can represent a decimal number 1234 with their positions of each digit. Okay. First we can look from the right side. Okay. First digit, that is 4, it is present at the units position or ones position. Second digit 3, it is present at tens position. And third digit it is present at hundreds position. And fourth digit it is present at thousands position. Okay. So this is how we represent a decimal number along with the positions of each digit. Okay. So in a number system, a value of a number not only depend upon their digit but also by their position, and this is known as positional value system or positional value notation. Each position in a positional value system, they represent the power of a base. What do you mean by power? Power is the number of times a base is multiplied by itself. We know that in decimal number system, the base is 10. For a decimal number system, the base is 10. Okay. And power means we are multiplying this base a number of times. For example, I can multiply this base 2 times. I can multiply this base 3 times. I can multiply this base 4 times. So, power means we are multiplying the base by itself for a number of times. Okay. And a power has been written to the right of a base as superscript. What do you mean by subscript and superscript? You have studied what a subscript is. That is, a number is being written at the bottom right corner of another number. Okay. A number is being written at the bottom right corner of another number. This is subscript. And superscript means a number is being written at the top right corner of another number. A number is being written at the top right corner of another number. This is what we mean by superscript. And a power is being written to the right of a base as superscript. So our base here is 10 and we will be writing the power at the top right corner as superscript. Okay, this is how we write power. And next point is power of digit at units position is 0 for any base, and power of digit at tens position is 1 for any base. We, for example, take the decimal number system 1234. Okay. And inside this we have studied the first digit, that is 4. It is at units position. And the power for the first digit or the power for the digit at units position will be 0. Okay. The power for the digit at units position will be 0. And the power for the digit at tens position will be 1. Okay. This is the digit at tens position and its power will be 10 raised to 1. And in hundreds position, the power will be 10 raised to 2. And for the digit at thousands position, its power will be 10 raised to 3. Okay. So as we are moving from right to left, the power increases. The power first starts from 10 raised to 0. Okay. Power first starts from 10 raised to 0. That is, for first digit or the digit at units place, the power will be 10 raised to 0. For the digit at tens place, the power will be 10 raised to 1. For the digit at hundreds position, the power will be 10 raised to 2. For the digit at thousands place, the power will be 10 raised to 3. Okay. So as we are moving from right to left, the power increases. And always the power for the first digit or the digit at units position will be 0. Okay. And let us see how we can represent a decimal number in this form of powers. Okay. For that, we can take the decimal number, that is 1234. And here we have studied the power for the units position, digit at unit position will be 10 raised to 0. So it is written as 4 into 10 raised to 0. And the power for the digit at the tens position, it is 10 raised to 1. So it is been written as 3 into 10 raised to 1. And in hundreds position, the power is 10 raised to 2. So this has been written as 2 into 10 raised to 2. And in hundreds position, the power is 10 raised to 3. So that digit at thousands position has been multiplied with the power. Okay. So we know that 10 raised to 3 means it is 1000. So 1 into 10 raised to 3 means 1000. And 10 raised to 2, it's 100. And 2 into 100 is 200. 10 raised to 1 means 10. So 3 into 10 is 30. And 10 raised to 0 means it is 1. So 4 into 1, it is 4. So by adding these numbers, we will be getting 1234. Okay. So this is how we can represent the decimal numbers in the form of their power. Okay. The second type of number system is binary number system. We know that computer understands only binary forms, that is ones and zeros. And in binary number system, there are only two states, that is on and off. Also known as ones and zeros. That is on stands for 1 and off stands for 0. Okay. In binary number system, we use only two states, that is ones and zeros, or on and off. Since we use only two digits, or we use only two states, the base of a binary number system will be 2. Okay. The base for a binary number system is 2. In decimal number system, the base was 10. Why? Because it consists of 10 digits. Here in binary number system, we use only two digits. They are 1 and 0. So the base will be 2. And the binary number is represented in this form. Okay, this is how we represent a binary number. There are ones and zeros, and we'll be writing the base as the subscript. How did we represent decimal number systems? It was represented like this. Okay, 10 was the base. And here in binary number system is being represented as this form. Okay, that is there are ones and zeros, and we'll be writing 2 as the subscript. Similarly, like decimal number system, binary number system also has got power of base. That is, each position has got the power of base. That is, the digit which is present at first position or the units position, its power will be 2 raised to 0. And for a digit which is present at tens position, its power will be 2 raised to 1. For a digit which is present at hundreds position, its power will be 2 raised to 2. And for a digit which is present at thousands position, its power will be 2 raised to 3. Okay. Similarly, like decimal number system, as we are moving from right to left, the power increases from 0 to higher numbers. Only difference between decimal number system and binary number system is that in decimal number system, the base was 10. So the power was represented like this. 10 raised to 0, 10 raised to 1, 10 raised to 2. Here, the base is 2. So the power is represented as 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, etc. Okay. So once again, binary number system, we use only two states, that is on and off or 1 and 0. Since two numbers are being used or two digits are being used, the base is 2. The binary number has been represented or written in this form. Similarly, like decimal number system, binary number system also has got power of base. That is, the first position or units position is 2 raised to 0. For tens position, the power is 2 raised to 1. For hundreds position, the power is 2 raised to 2. And for thousands position, the power is 2 raised to 3. So this is about binary number system. Our next topic is about conversion of numbers. Okay, that is, we can convert a binary number into a decimal equivalent number, and also a decimal number can also be converted into a binary equivalent number. And first let us study how we can convert a decimal number into a binary number. For that you have to follow some steps. Okay, first step is divide the decimal number with base 2. Step number 2, note the remainder to the right of the dividend, since we are converting a number into its binary equivalent. Therefore, if the dividend is even, the remainder will be 0, and if the dividend is odd, the remainder will be 1. Step 3, divide the quotient again by 2. The quotient becomes the dividend in the next successive division. And step number 4, repeat step 2 till the quotient is 0. And step number 5, write the remainders in the reverse order. Okay, so for converting a decimal number into a binary number, these are the steps that you have to follow. And I'll be explaining to this how to convert a decimal number into a binary number with an example. Then you will be having a clear idea about what these steps means. Okay, so understand that we can convert a binary number into a decimal number, and also a decimal number can be converted into a binary number. That is what I mean by conversion of numbers. And first we are studying about how to convert a decimal number into a binary number. For that you have to follow some steps. Okay, so we have seen the steps of converting the decimal number into its binary equivalent, and now we can see with an example how to convert a decimal number into its binary form. So for that, first I have taken the decimal number 25. I want to convert the decimal number 25 into its binary form. Okay, so for that you have to follow the steps that you have read before. Okay, first step was you have to divide the decimal number with the base 2. Okay, here the decimal number that I want to divide is 25, and I have to divide 25 with base 2. Why base 2 is being used? We know that we are converting a decimal number into its binary form, and in binary number system the base is 2. Okay, that is why we are dividing the decimal number with a base 2. Okay, so first step is you have to divide the given decimal number with base 2. So my dividend becomes 25 and my divisor becomes 2. Okay, I am going to divide 25 by 2. So dividing 25 by 2, the quotient that I got is 12, and I am going to write that quotient over the dividend section, and the remainder that I got is 1. Okay, I am going to write that remainder over here. Okay, and next step, what is given? You have to continue the process of division until the quotient becomes 0. See here, by dividing 25 by 2, the quotient that I got is 12. It is not a 0 value, so I have to continue the process of division. That is, I have to continue dividing 12 by 2. So dividing 12 by 2, the quotient that I got is 6, which is not a 0 value. So I am going to write the quotient over here, and the remainder that I got is 0. See, still the quotient is not a 0 value. So again I have to continue the process of division. That is, I have to divide 6 by 2. Dividing 6 by 2, the quotient will be 3. Okay, dividing 6 by 2, the quotient is 3. And the remainder is 0. Still the quotient has not become a 0 value. So I have to continue the process of division. 3 divided by 2. Dividing 3 by 2, the quotient that I got is 1. And the remainder that I got is also 1. Still the quotient has not become a 0 value. So I have to continue the process of division. Dividing 1 by 2. Am I able to divide 1 by 2? No. Division is not possible. So my quotient becomes 0. And what will be the remainder? Remainder will be 1. Okay. That is, dividing 1 by 2 is not possible. It's not possible. So the quotient becomes 0 and the remainder becomes 1. Okay. Quotient becomes 0 and remainder becomes 1. See, now my quotient has become 0. So now I can stop the process of division. Here I can stop the process of division since the quotient that I have got is a 0 value. Okay. Now look at the remainder section. In the remainder section you have got ones and zeros, which are binary forms. Okay. And always remember that if your dividend is an odd number, say 25 is an odd number, and if you are dividing this 25 with 2, the remainder that you will be getting is 1. Okay. That is, if your dividend is an odd number, the remainder that you will be getting is 1. If your dividend is an even number, say 12 is an even number and I am dividing 12 by 2, the remainder that I got is 0. Okay. So if your dividend is an even number, your remainder will be 0. See, next number is 6. You are dividing 6 by 2 and 6 is a even number. Okay. That is, your dividend is an even number and the remainder that you got is 0. Next number is 3. 3 is an odd number. You are dividing 3 by 2. The remainder that you got is 1. Okay. So always remember, if your dividend or your quotient is an even number, your remainder will be 0. If your dividend is an odd number, your quotient, your remainder will be 1. Okay. So we have divided the number 25 with base 2 and we have continued the process until we got the quotient as 0. Now we can stop the process of division. And you have to write the binary form. For writing the binary form, you have to look on to the remainder section. In the remainder section, there are ones and zeros, which are binary form. Okay. And for writing the binary form, there is a specialty. That is, you have to go from downward to upward. Okay. You will be writing the binary form from downward to upwards. That is, first you will be writing 1 and you will be writing 1. Next you will be writing 0, 0, 1. So this is the binary form for the, this is the binary form for the decimal number 25. Okay. That is, you have to take the reverse of the remainder for writing the binary form. Okay, for writing the binary form of a decimal number, you have to take the reverse of the remainder section. And now I have converted the decimal number 25 into its binary equivalent. Okay. So this is how you have to convert a decimal number into its binary form. That is, first step is you have to divide the given decimal number with base 2. And the quotient, if you are getting a non-zero value, you have to continue the process of division. I have got 12 as the quotient, so I have to continue the process of division. Again, I divided 12 by 2. The quotient that I got is 6. It is not an 0 value. So again, I have to continue the process of division. And I continued the process of division until I got the quotient as 0. Okay. Once I got the quotient as 0, I will be completing the process of division. And I will be looking on to the remainder section. Okay. In the remainder section, you have to take the reverse of the remainder form. That is from downward to upward. That is the binary form of the corresponding decimal number. Next, let us look at another example. That is, I want to convert the decimal number 30 into its binary equivalent. Okay. So first step is you have to divide the decimal number, given decimal number with base 2. Okay, I am dividing 30 by 2, 6 times 12 remainder. So the quotient that I got is 6 and the remainder is 1. See, 6 is not a 0 value, so I have to continue the process of division. I am dividing 6 by 2. Dividing 6 by 2. Dividing 6 by 2, the quotient that I got is 3 and the remainder is 0. Okay. 3 is not a 0 value, so I have to continue the process of division. Dividing 3 by 2. Dividing 3 by 2, the quotient that I got is 1 and the remainder is also 1. Okay. See, the quotient is still not a 0 value, so I have to continue the process of division. Dividing 1 by 2. We cannot divide 1 by 2. So the quotient becomes 0 and the remainder becomes 1. See, the quotient has become a 0 value. So I can stop the process of division. For writing the binary form, you have to look on to the remainder section. That is, the reverse of the remainder is the binary form. Okay, the reverse form of the remainder, it is our binary form. So our binary form will be 1101. Okay, that is, the decimal number 30 has got the binary form 1101. Okay, hope all of you are clear with how to convert a decimal number into its binary equivalent. And with this, I am ending my class today. Thank you.